The German engineer stopped mid-step and stared at the American tank in front of him. Something about it felt wrong. Not wrong in the way a floor feels wrong. Cracked armor, sloppy welding, rushed assembly. Wrong in a far more unsettling way. Wrong because everything he had been taught about American industry was suddenly collapsing in front of his eyes. It was April 1943, and the tank stood inside the Kummersdorf Proving Grounds, Germany's most secretive and prestigious weapons testing facility, located roughly 20 miles south of Berlin. This was the same place where German rockets had first screamed into the sky, where the Wehrmacht tested every major weapon system before it reached the battlefield. Only the Reich's best engineers were allowed inside. And now, standing beneath the cold German lights, was an American M4 Sherman tank captured in North Africa. Its serial number was USA-3067-641. The Americans had named it War Daddy II. It had been captured on February 22nd, 1943, during the chaos following the Battle of Sidi in Tunisia. That battle had been a disaster for American armored forces. German panzer divisions had slammed into the 1st Armored Division, shattering inexperienced units and driving them back toward Kasserine Pass. Tanks were abandoned in retreat. Crews fled under fire. Equipment was lost. But this tank was different. German recovery teams had found War Daddy II intact. No catastrophic damage, no burned-out engine, no twisted hull. And unlike most captured vehicles, when they turned the ignition, it started on the first attempt. No hesitation, no coughing engine, just a smooth mechanical hum. The Germans drove it more than 200 miles across the desert to Tunis. 4.5 days of punishing heat, sand, and vibration. No breakdowns, no mechanical failures. From Tunis, it was loaded onto a ship and transported to Germany for full evaluation. German High Command wanted answers. They wanted firing tables, armor diagrams, weak points. They wanted proof that the Sherman was inferior, thin-skinned, poorly built, a crude product of American mass production. Intelligence reports had dismissed it as a temporary nuisance. Thin armor, weak gun, built by a nation that had never fought a modern armored war. This evaluation was supposed to confirm that belief. The engineers approached the Sherman with the quiet arrogance of master craftsmen inspecting a cheap imitation. They expected ugly welds, brittle steel, poor tolerances. They were prepared to write a report that would reassure generals and justify continued investment in Tigers and Panthers. Instead, the first thing they noticed was the welding. It wasn't just strong. It was clean, uniform, machine perfect. The engineer ran his fingers along the seams where armor plates met. There were no irregularities, no signs of rushed handwork. This wasn't artisan craftsmanship. This was something far more dangerous. This was industrial precision repeated thousands of times. Germany was crafting masterpieces. America was printing tanks. They began the evaluation methodically. Every armor plate was measured, every angle calculated. Numbers were stenciled directly onto the hull in white paint. The armor thickness was adequate but unremarkable. 51 millimeters on the front hull, 38 on the sides. A Tiger could punch through it at over a mile. On paper, the Sherman should have been outclassed. Then they opened the engine compartment. Inside sat a Continental R975 radial engine, an aircraft engine adapted for tank use, air-cooled, 400 horsepower, designed to run reliably at altitude where mechanics couldn't easily reach it. The Americans hadn't designed a tank engine from scratch. They had taken something already proven and repurposed it. That decision alone disturbed the engineers. The Sherman weighed roughly 30 tons, giving it about 13 horsepower per ton. The German Panther weighed 45 tons with a 700 horsepower engine, resulting in only slightly better power to weight despite being 50% heavier. But raw power wasn't what impressed them. Any nation could build a powerful engine. What shocked them was access. Every major component could be reached through large service hatches. Oil changes took minutes. Spark plugs could be replaced without specialized tools. A mechanic with basic training could keep the engine running indefinitely. German tanks were the opposite. The Panther's Maybach engine required factory-trained specialists. Cooling problems caused frequent fires. Replacing major components often required cranes and full workshops. The Americans had built a tank that could be fixed in the field. The Germans had built tanks that had to be shipped home. As the engineers continued, the realization grew darker. This wasn't a poorly made machine. This wasn't an inferior design. This was a weapon built around a completely different philosophy of war. And the longer they examined War Daddy 2, the clearer it became that Germany had misunderstood its enemy at the most fundamental level. This tank was not designed to be the best on the battlefield. It was designed to always be there. And that difference would decide the war. The deeper the engineers went, the more uncomfortable the room became. At first, the Sherman had seemed merely competent, solid, practical. But as the examination continued, competence began to look like something far more dangerous. The transmission housing was opened next, and what the German engineers saw there forced several of them to stop taking notes altogether. German tanks screamed. That was the sound they were used to. Spur gears, straight-cut teeth grinding against each other under load, metal fighting metal. It was loud, violent, and familiar. Every German tanker knew the sound of his own transmission screaming beneath him, a reminder that speed came at a price. The Sherman did not scream. When the powertrain was engaged, it produced a low, steady hum. Smooth, controlled, almost unsettling. One engineer thought something was wrong with the test equipment. Another leaned closer, placing his hand against the housing to feel the vibration. Herringbone gears, precision-cut, angled teeth meshing together in perfect alignment. The kind of gears used in heavy industry, locomotives, and ships. The kind of gears that could run for thousands of miles without catastrophic wear. German engineers knew exactly what they were looking at, and exactly why Germany did not use them. Herringbone gears required complex machining. They required specialized gear-cutting tools. They consumed tungsten carbide at a frightening rate, and tungsten carbide was a strategic material Germany no longer had in abundance. Allied blockades had strangled access to it. German industry had adapted by simplifying designs, accepting shorter lifespans in exchange for faster production. The Americans had made the opposite choice. The Sherman's transmission was rated for approximately 3,000 miles before overhaul. The Panther's final drive, under combat conditions, often failed after 100 miles. Not 100,000, not 10,000. 100. The engineers did the math in silence. A Sherman could drive from Normandy to Berlin under its own power. A Panther could barely make it from a railhead to the front line without risking failure. No amount of armor or firepower could compensate for that reality. And still, the worst discovery was yet to come. When the engineers turned their attention to the gun mount, they noticed a small rectangular box attached near the breech of the 75mm gun. Electrical cables ran from it toward the gunner's position. At first, they assumed it was some crude electrical assist or firing mechanism. It was neither. It was a gyroscopic stabilizer. The realization hit them slowly, and then all at once. The Americans had installed a gun stabilization system in a mass-produced medium tank. Not an experimental prototype, not a limited run. Tens of thousands of Shermans carried it. German engineers had experimented with stabilizers for years. They understood the theory. They understood the advantage. They had simply never been able to manufacture one small enough, robust enough, and cheap enough to survive tank combat. The tolerances required were extreme. The electronics demanded precision manufacturing that Germany's bombed and resource-starved industry could not sustain. The Westinghouse system used in the Sherman was not perfect. It stabilized the gun only in the vertical plane. It did not allow true firing accuracy while moving at speed. But it did something far more important. It kept the gun roughly on target. That meant that when a Sherman stopped, even briefly, the gunner could fire almost immediately. German tanks needed time, 10 seconds, 15. Time for the suspension to settle. Time for the gun to stop oscillating. Time that often meant death. In armored combat, the first accurate shot usually decided the fight. The engineers documented the stabilizer carefully. They calculated what it would take to replicate it. The conclusion was brutal. Germany could not. Not with the materials available. Not with the machine tools they possessed. Not within the time the war allowed. And then War Daddy 2 was ordered to Hillersleben. Hillersleben was not a laboratory. It was a stage. In June 1943, senior officers from across the Wehrmacht gathered there to witness a demonstration. These were the men who controlled production priorities, men who decided how steel, fuel, and labor would be allocated. They were not interested in quiet reports or uncomfortable conclusions. They wanted proof. A climbing test was prepared. A steep 30-degree slope of loose sand. The Panther went first. It surged forward effortlessly. Wide tracks bit into the surface. The powerful engine roared. The tank crested the hill without hesitation. The generals smiled. Then came War Daddy 2. Its narrower rubber block tracks struggled for traction. The engine whined. The tracks spun. The tank slid backward, defeated by the slope. The Sherman failed the test. Applause followed. To the generals, the demonstration confirmed everything they wanted to believe. German engineering was superior. American tanks were inferior. The decision to continue building Tigers and Panthers was justified. The engineers saw something very different. The Panther had won a sprint. The Sherman had already proven it could survive a marathon. War Daddy 2 had driven more than 200 miles across the Tunisian desert under its own power before ever reaching Germany. A feat many Panthers could not match without catastrophic breakdowns. The hill at Hillersleben proved nothing that mattered, but nobody wanted to hear that. And then Albert Speer arrived. As Reich Minister of Armaments, Speer controlled German war production. He had reorganized factories, streamlined output, and dramatically increased weapons production in 1942. He believed that German efficiency could still overcome Allied numbers. Photographs show him examining War Daddy 2, reading reports, speaking with engineers. He understood the problem immediately. Later, Speer wrote that reports from Italy praised the Sherman's cross-country mobility. American tanks climbed terrain German experts considered inaccessible. The power-to-weight ratio gave them superior sustained movement. But Speer grasped something deeper. Germany was building machines that required rail networks to survive. America was building machines that were the rail network. Shermans drove themselves to the front. They did not need specialized crews. They did not need constant factory-level maintenance. They did not need perfection. They needed availability. The Sherman was not just a tank. It was an industrial philosophy made steel. American designers had prioritized reliability, maintainability, and mass production. They accepted a weaker gun because ammunition was plentiful and logistics mattered more than penetration tables. They accepted thinner armor because weight reduction increased mobility and reduced mechanical stress. They accepted simpler designs because simpler machines could be built faster, repaired easier, and replaced without hesitation. Germany had optimized for technical superiority and optimized itself into defeat. Tank crews understood this long before generals did. Alfred Rubbel, a Tiger commander in the 503rd Heavy Panzer Battalion, later described captured Shermans as reliable civilian cars. You turned the key, and they started. Tigers required rituals, warm-up procedures, constant fear of transmission failure. German tanks were terrifying when they worked. They simply did not work often enough. By 1944, German armored units reported operational readiness rates between 35 and 45%. More than half of their tanks were non-operational at any given time. American units maintained readiness above 85%. In Normandy, roughly half of all abandoned Panther tanks were destroyed by their own crews due to mechanical failure. Not enemy fire, mechanical failure. By the Battle of the Bulge, 60 to 70% of German heavy tank losses were non-combat related. Fuel shortages, broken transmissions, overheated engines. The engineers at Kummersdorf had seen this coming. They had documented every warning sign. They had explained why American manufacturing would win the logistics war. They had shown that reliability beat brilliance. Nobody listened. Germany could not change course. Strategic materials were gone. Precision tooling was unavailable. Factories were built around skilled craftsmen, not interchangeable parts. Ideology demanded technical superiority. Admitting American methods were better would shatter the myth of German engineering dominance. So Germany kept building masterpieces. America built 49,324 Shermans. Germany built about 6,000 Panthers and 1,347 Tigers. The math was merciless. A Tiger could destroy 5 Shermans. There would be 6 more tomorrow, and the Tiger would be waiting for a transmission that might never arrive. This war was not decided by kill ratios. It was decided by availability. War Daddy 2 had shown them the truth in April 1943. Reliability beats perfection. Availability beats capability. Working beats superior every single time.